A ship moves along the equator to the east with velocity v naught is equal to 30 km per hour. The southeastern wind blows at an angle phi is equal to 60 degree to the equator with velocity v is equal to 15 km per hour. Find the wind velocity v dash relative to the ship and the angle phi dash between the equator and the wind direction in the reference frame fixed to the ship. Okay, so in this problem what we have been already given is the velocity of the ship with respect to a fixed point on the equator. So let us say that our fixed point is the origin O at this point, and we are given that the ship is moving towards the east. So I have taken my positive x axis to be towards east, and north is my positive y axis, so south will be my negative y axis. So we are already given that ship is traveling towards the east when measured from or when viewed from the point O, which is a fixed point on the equator, and from the same point there is a wind that is blowing in the southeastern direction, and we are also given the angle, that is we are given the angle, this angle we are given, which is phi. So we have been given this angle, but all this is measured relative to the fixed point O on the equator. So what we are supposed to find out, that if we fix our coordinate system on the ship, that is suppose you are standing on the ship, then what would be the velocity and the angle of the wind that you will feel while standing on the ship. So this is a straightforward relative velocity question. Now we know that relative velocity of an object is given by, for example, we have the, suppose we have an object moving with the speed v in the fixed reference frame. Then if suppose we have another reference frame which is moving with velocity v naught with respect to the fixed reference frame, then the relative velocity of that same object is given by v dash is equal to v minus v naught. So in our case we simply apply this formula. We know v, that is we know the speed of wind with respect to O. We know the v naught, we know the ship speed with respect to point O. So both these things we know. So v dash is simply v minus v naught. So remember that this is a vector calculation. So what is v minus v naught? This is v, this is v naught. So v minus v naught is also a vector which is simply this vector over here, which is simply this vector, and the direction of this vector will be this direction, and you can verify this, that is v naught plus v is equal to, and this is our v dash vector. So all we have to do is we have to find this v dash vector. Now simply applying, if you apply law of cosines, law of cosines is applying this. So from law of cosines we get v dash square is equal to, this length is v square plus this length is v naught square minus 2 times V times V naught cos phi, and therefore V dash is equal to, and therefore we get V dash is equal to square root of V naught square plus V square minus 2 times V times V naught cos phi. Now we already know all the values here, so we can get this one as V naught square is 900, which is 30 square. V square is 2 to 5, which is 15 square, minus 2 times V naught is 2 times 15 is 30, 30 times 30 is 900, 900 times cos 60 is half, so we get minus 450. And this is equal to 450 plus 225 is equal to 675. This can be written as 2 to 5 into 3 is equal to 15 root 3 kilometers per hour. So this is the speed of the wind that the captain on the ship will feel. Next question is finding out the direction. Now for finding direction, we can again use trigonometric identities. We already know that this angle here is what we are supposed to find. This is phi dash. This angle is phi dash, and we are supposed to find this angle. So for finding the angle, we can apply law of sines. So we know V dash, we know V, we know phi, we have to find phi dash. So applying law of sines, we get (15√3), that is this side, V dash divided by sine phi is equal to V is 15, 15 divided by sine phi dash. Now this implies that sine phi dash is equal to 15 sine phi divided by 15 times root 3. Phi is 60 degrees, so we know that 15 into root 3 by 2 divided by 15 root 3, and this cancels out, this 3 cancels out here, and we get half. So phi dash is equal to sine inverse of half, which is 30 degrees, or pi by 6. So we have to tell the angle with respect to the equator. So actually the correct angle is because correct angle that we have to report is this angle. So this is pi plus pi by 6. So finally our answer is phi dash is equal to pi plus pi by 6, and this is equal to 7 pi by 6. So our angle is in the third quadrant.